Welcome. We're going to take a look here at how a vector valued function can trace out a curve in space. I'm using here an application called CalcPlot 3D, and when I open the application on the website, it already has a surface preloaded. That's not what I'm interested in, so I'm going to come up here and delete that function. Now what I want to do is I want to graph a curve in space, so I'm going to add to my graph here what's called a space curve. Now the space curve that I'm interested in is the curve cosine of ti plus sine of tj plus 0.1 tk. So we have those set up in kind of parametric form here, ready to go. So I'm going to go ahead and check the box, and here's the curve. As we can see, it looks like a spring. It's mathematically, we call it a helix. But what I want to do is just take a minute and let you see how a space curve or how a vector valued function traces out a space curve, in this case a circular helix. So we want to trace, and we're going to come into our settings here, and I don't need to see the velocity and acceleration. I don't need to see the vector equations for what I want us to notice. I'm going to go ahead and make the width of the curve and the trace point just a little bit bigger. Okay, now what I'm going to do is this is set up to graph the curve from t equals -10 to 10, and so we're just going to animate that, and as you see there's a vector in blue. I'm going to stop it here in just a second. And this vector here is the vector cosine of t, sine of t, 0.1 t, when t is equal to 4.88. And this vector points to a point on the curve, and it's the collection of all of these little points on the curve that creates the helix that we're seeing. So as we animate it again, t is going to increase, and our vector here is going to rotate because t is increasing, and we're going to watch the point on the curve. The black point is the actual point on the curve as it moves up the helix. So I'll watch it again. We can see the position vector tracing out the curve, the black point being the points along the curve. I hope you find this helpful.